Finally, we've got question 22. Prove algebraically that the difference between the squares of any two integers is equal to the sum of those two integers. Now, I hate to prove it questions, but this one doesn't look too bad, so let's give it a go. The fact that they are consecutive makes it a little bit easier. So let's start with, well, one of those integers can be n, and the other one can be n plus 1. They're consecutive. One is next to the other. Yeah? So this number, if it was 5, that would be 5 plus 1, which is 6. If it was 7, it would be 7 plus 1, gives you 8. So they are consecutive. Okay? Now, we're proving that the difference between the squares of them, and the difference between, so difference means take away, squares means we're going to square it, and in fact we've already done consecutive. So, let's do n plus 1 squared, take away n squared. And we're expecting it to equal the sum of those two together. So if I added those two together, it will be 2n plus 1. So if we square this one, you get n squared plus 2n plus 1. And then we've got minus n squared. And then we can collect our like terms. Well, n squared take away n squared, leaves you with nothing. So that's 2n plus 1. Amazingly, that equals, yeah, that means prove it, n plus 1. Done.